Okay, so welcome back to my first video, and today we'll be seeing some forms of different types of equations. We're going to talk about linear equations and absolute value equations. So the general form for a linear equation would be y equals mx plus b. But today I want to talk about a form that goes by m minus h plus k. And this is point slope form, but with different variables. This is supposed to be x1 and k is supposed to be y1. And this is modified point slope, so you won't have y minus y1. The y1 is just moved to the other side. So instead of m, we're going to use a. And that would be a linear equation. So HK, the point HK represents a point on the graph. And the way you graph a modified point slope form is you find HK, and it already gives you negatives. So if this is x plus 4, if h was like negative, then negatives will cancel out and it should be h plus 4. And h moves the graph left and right, and we have k that moves the graph up or down. A determines the steepness of the graph. Now this will be really steep and then this will be really flat. And this, no matter how much you will change hk, this is a point that will be on the graph. And if you change this, it'll still be on the graph. So I could show you an example here of what I mean. Like, you could have different numbers in modified point slope form, but it would be same graph. So here's an example of modified point slope form. Now you could also do this. I would say, actually, I'm gonna make this like 8. That'll be like 8. Still gonna have this. Instead, if I wanna get -8, then I could do 12 plus 4, I think. So these two equations are the exact same thing. Even though they look a bit different, HK could be different, but they could be the same equation. It's hard to show, but you could see that the color changes, meaning it's the same graph. Those are examples. This would be the vertex. Vertex is for like absolute value equations and quadratic. This is the point. And once you know HK, you can just graph using the slope. So with slope, you can just go down and go right by this much. So while graphing the slope, just like with mx plus b, you could just graph this line like that. Now there's also another equation that uses a very similar process, but it's called the absolute value. It's a regular form of the absolute value equation. So in parentheses, we have absolute value thing. So actually, I think I'm gonna make this a different color. I'm gonna make the absolute value one blue. So uh, the absolute value, I'm gonna hide this. It also makes it like steeper or flatter. This will make it vertically stretch, and this will make it vertically compress and flex. This is more of the vertex than vertex. And same properties, HK. And this is one way to plot linear functions and absolute value functions, and I really think this is interesting because you can graph it you could just find a coordinate right inside the function. But I would prefer for the linear function, I would prefer y equals mx plus b because that's the most simplified way. If you just distribute this, it'll turn out to be ax, then ax minus, if you do ax, then you have ax minus 8, so that's minus a8, wait, minus ah, then we have just plus k. That is, yeah, it's basically just you could solve for that, and you could only get like a term with x, and the term with a, h, and k are all numbers. So I prefer y equals mx plus b because it's really simple. But with absolute value functions, you cannot use that because, you know, there's many slope intercepts. Like you don't use slope intercepts when you're using the absolute value function. You would use this notation to graph the absolute value function. Thank you for watching and hope you have a great day.